we will now discuss the solution of a problem from the section Sequences and Series. This present problem is on the sum of the given series. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the first shift. The given question is, let n is equal to 0 to infinity be a sequence such that a0 is equal to a1 is equal to 0 and an plus 2 is equal to 2 times an plus 1 minus an plus 1 for all n greater than or equal to 0. Then sigma n is equal to 2 to infinity an by 7 to the power of n is equal to, we are given 4 options. Option A, option B, option C, option D. We are given a sequence n is equal to 0 to infinity, whose initial terms, initial first two terms, that is a0 and a1, each is equal to 0. And the other elements of the sequence are given by this recurrence relation. That is an plus 2 is equal to 2 times an plus 1 minus an plus 1 for all n greater than or equal to 0. Then required to find the sigma n is equal to 2 to infinity an by 7 power n. This is the sum of this series. Great. We will now discuss the solution of the problem in detail. We have the sequence an is equal to 0 to infinity, whose first two terms a0 is equal to a1 is equal to 0, and we are given a recurrence relation an plus 2 is equal to 2 times an plus 1 minus an plus 1 for all n greater than or equal to 0. Agreed. Now required to find the sum sigma n is equal to 2 to infinity an by 7 power n. Let us denote this sigma n is equal to 2 to infinity a suffix n by 7 power n as s, the sum of this series. Agreed. Now an plus 2, we are given the recurrence relation an plus 2 is equal to 2 times an plus 1 minus an plus 1. Now multiply throughout by 1 by 7 to the power of n plus 2. So multiply each term by 1 by 7 to the power of n plus 2. So we have multiplied. Now an plus 2 by 7 to the power of n plus 2, we keep it as it is equal to 2 into an plus 1 by 7 to the power of n plus 2. We will write it as an plus 1 by 7 to the power of n plus 1 to adjust the terms 1 by 7. Minus an by 7 to the power of n plus 2, 1 by 7 square you take out, then it will be 1 by 7 square into an by 7 to the power of n. This keep it as it is. So we write this one. So 2 by 7, here minus 1 by 49, and this we will get this relation. Now take the sigma as n is equal to 2 to infinity. From n is equal to 2 to infinity, take this sigma. That means sum up all the series. Sigma n is equal to 2 to infinity on both the sides. That will be sigma n is equal to 2 to infinity an plus 2 by 7 to the power of n plus 2 is equal to 2 by 7 into sigma n is equal to 2 to infinity an plus 1 by 7 to the power of n plus 1 minus 1 by 7 square into sigma n is equal to 2 to infinity an by 7 power n plus sigma n is equal to 2 to infinity 1 by 7 to the power of n plus 2. Let's call this relation as the relation 1. We continue in the next slide. So this is what we have done so far in the first slide. Right. Let us take the first one. Sigma n is equal to 2 to infinity an plus 2 by 7 to the power of n plus 2. Look at this. Look at this. So n is equal to 2 means the first term will start from a4 by 7 power 4. The next one is a5 and so on and so forth. But our s is sigma n is equal to 2 to infinity means it starts from 2 onwards. 2 onwards. So in this, the second term and the third term is missing. So if I write s, that means from this s, if you subtract the first two terms, then you will get this. Because it starts from n is equal to 2 means a4 by 7 power 4 onwards. So that is why sigma n is equal to 2 to infinity an by 7 power n minus, and the first two terms are missing from here. So minus a2 by 7 square plus a3 by 7 cube. This is the second term, third term. Now, by the way, what is a2 and what is a3? We know a0, we know a1, and we know the recurrence relation. But we will now compute what is a2 and a3. We have a0, a1 is equal to 0, and the recurrence relation is here. In this, put n is equal to 1. Then you will get a3 in terms of 2. So it will be n is equal to 0, say right. N is equal to 0. In this we have put, we get a2 is equal to 2 times a1 minus a0 plus 1. And a0 is 0, a1 is 0, so it is 1 only. If you substitute, so thus we got a2. To get a3, put n is equal to 1. Put n is equal to 1. N is equal to 1. Then it will be a3 is equal to 2a2 minus a1 plus 1. In this, a1 is 0, a2 is 1. So 2 into 1 plus 1, that is 3. So we know a2, we know a3. Come back here and substitute. So that will be equal to, this is your s, this is your s. S minus 1 by 7 square minus 1 by 3 power 7 cube. Agreed. Take this blue one. That is a sigma n is equal to 2 to infinity an plus 1 by 7 to the power of n plus 1. N is equal to 2. The first term starts in this is a3 by 7 cube. But in S, it starts from n is equal to 2. That means a2 by 7 square. That means from S, you have to subtract the second term. That is a2 by 7 square. Then you will get the sequence. The series starts from n is equal to 2 means a3 by 7 cube. So from this, we have taken out the first a2 by 7 square, but a2 we have already computed, that is 1. So this is s minus 1 by 7 square. Right. This pink one you take, that is sigma n is equal to infinity 1 by 7 to the power of n plus 2. Put n is equal to 2, 1 by 7 power 4. Put n is equal to 3 plus 1 by 7 to the power of 5 plus so on and so forth. That means it is a geometric series whose first term is 1 by 7 to the power of 4 and the common ratio is 1 by 7. And the sum is up to infinity. The sum is given by a by 1 minus r. A is 1 by 7 to the power of 4 by 1 minus r, 1 minus 1 by 7. Simplify, you will get 1 by 6 into 7 cube. So there's the relation 1 now becomes this one. Sigma n is equal to infinity an plus 2 by 7 to the power of n plus 2 is s minus 1 by 7 square minus 3 by 7 cube. And that is equal to 2 by 7 into sigma n is equal to 2 to infinity an plus 1 by 7 to the power of n plus 1 is s minus 1 by 7 square minus 1 by 7 square into sigma n is equal to infinity an by 7 power n is 1 minus 1 by 7 square s plus sigma n is equal to 2 to infinity 1 by 7 to the power of n plus 2 is 1 by plus 1 by 6 into 7 cube. So all the terms have come. And now segregate the terms in containing s on to the one side. Let us take it to the left hand side. That will be s minus 2 by 7 s and plus 1 by 7 square s, because we are taking to the left hand side. And on the right hand side, minus 2 by 7 cube plus 1 by 6 into 7 cube, and these terms take to the right hand side, plus 1 by 7 square plus 3 by 7 cube. Now take the LCM in this. So the LCM is 7 square. So, and take the LCM on the right hand side, it is 6 into 7 cube. Then compute. So after computation, this is what we get. After simplification, we will get 36 by s square. This is 36 by s square. 36 by 7 square is equal to s is equal to 49 by 6 into 7 cube. We want s. Sigma n is equal to infinity an by 7 power n. We want s. So S is equal to 49 by 6 into 7 cube multiplied by 7 square by 36. After cancellation, you will get 7 by 216. Let's look at our options. Our answer, S by 216, appears against option B. Therefore, the answer to this question is option B. And that is the detailed discussion of the solution of the problem from the section sequence and series. And the problem is on the sum of the given series. It is relatively easy but not very easy, moderately difficult, but many people might have solved problems like this in their class. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.